For this and the next few videos, we're going to be returning to the Video Easy schema, where we were working with actors, films, and rentals. And with these tables, we're going to learn about inserting, updating, and deleting data. But for my demonstration purposes, I don't actually want to make any permanent modifications to the data in these tables. So I'll briefly introduce you now to something called transactions, which are incredibly powerful and useful in the world of relational databases. In the coming videos, I'm going to have all my data modification statements wrapped inside what's called a transaction block. In Postgres, I can start a transaction block by first running the begin command, and then, as you'll see in the coming videos, I'm going to put all my insert, update, and delete statements within that transaction block. And then finally, I'm always going to end with the statement rollback. When the rollback command is issued, any changes that were made since the transaction started will be discarded. So by putting all my statements in a transaction block, what that's going to do is allow me to make data modification statements, but then ultimately always undo that change when I issue the rollback statement, so that the database will always be returned back to its original state at the start of the transaction. If instead I actually wanted to confirm those changes and make them permanent, I would instead issue the commit command. But for my purposes, for demonstrating changes and then for undoing those changes, I'll always just be using the rollback command. And for this video, I'm going to be focusing on insert statements, inserting new records into your tables. Let's have a look at our schema and pick the table that we want to insert some records into. I'll go with the actor table. And what's quite nice in dbeaver is I can double click on that table, I can go down to DDL, and I can look at the create table statement that would create this table. So I can see the data types and I can see the different constraints that are present for this table. I want to insert some new actors into this table, so looking at this table definition can help me understand what columns I have to provide and which are optional, which get a default value assigned on insert. The actor ID is of type serial, so that's auto-generated by the database. First name and last name I clearly have to specify. Last update gets a default value, so I don't have to provide that on insertion if I don't want to. Let's go back to our script and write that insert statement now. So I want to insert into the actor table. I only need to insert two columns, the first name and the last name. And I write values, and then can provide the rows and the columns to get inserted. So I'll insert Keanu Reeves. I'll insert Tom Cruise. And I'll insert Winona Ryder. And immediately after running that insert statement, I'll run a select statement to pull back those results. And let's order them by their first name. So let's start by running these statements now one at a time. We'll first run begin. That starts the transaction. Next, I'll come down, I'll insert the new actors. Now I'll select from the actors table. Let's have a look at those results, and let's look for Keanu Reeves and some of those other new actors that we just inserted. There's Keanu Reeves. There's Tom Cruise, and I'm confident we'd find Winona Ryder in there as well. So remember though that I'm within a transaction block right now. So even though the actors table has been modified, and we verified that by running the select statement, that modification has not been made permanent. If I were to disconnect, for example, right now from the database, those changes to the actor table would be lost. It's only if you run the commit statement now that those changes that you made within your transaction are made permanent and written to disk. I don't want to do that though, so I'm just going to issue the rollback command. After doing that, let's actually just select from the actor table again. Let's scroll through and look for Keanu Reeves again. He's gone. Because we only performed that change within the transaction and then we rolled back that transaction, the change never happened, which is exactly what we wanted in this case. So working within a transaction block is a really safe way that we can experiment with changes in the coming videos. Okay, getting back to focusing on the insert statement, Something that's unique to Postgres is that whether you're using insert, update, or delete, you can also add a returning clause to the end of the statement. And what that will do is allow the insert, update, or delete statement to return the affected rows. For example, rather than following this insert statement with a select clause, what I could just do is write returning star. I can now run this as a script, selecting this execute script option, and that will run the begin statement, the insert statement, and then the rollback statement. Let's do that now. Notice how the insert statement produced some output. It returned me the 3 rows that got inserted. So that's really useful. If, for example, I was writing a script and I performed an insert, and I wanted to find out, well, what are the default values that got inserted for me? In this case, I couldn't know ahead of time what are the different actor IDs or what last update date is used. If I make use of this returning clause and add it to my insert statement, I can get access to those new actor IDs, which I might use later on in some way in my script that I'm writing. Much like you write your select clause, I can also write expressions here, so rather than just having return star, which will return all the columns from the inserted rows, I can also specify the columns that I want. So I'll run this as a script again, or I could write an expression. But I'll just stick with star for now because I just want to demonstrate the change that took place. A variation on specifying the exact values when performing the insert is to insert into a table the results of a query. Let's look at a simple case where I want to insert into the actors table several of the customers. Looking at our schema, I've decided I want to insert into the actor table some of the customers that have an active value of 0. Let's first just write a query to have a look at what we'd actually be inserting then. So there's 15 customers that have an active state of 0. What I can do is bring this query up, and instead of specifying the values, I can put it here. Indent it. And when I run this, what this will do then is insert into the actor table all of the results from that query. Let's run this as a script again. And we see that that inserts 15 new rows into the actor table, who get assigned actor IDs and last update dates. Just lastly on transactions, one thing I will mention is that if you're within a transaction block and you get an error, your transaction will end up in the aborted state, and you'll need to issue a rollback statement in order to be able to continue. So for example, if I start a new transaction now, I'll issue the begin command, and I'll just write a statement that doesn't work. The customer to table doesn't exist. I'll try to run this statement and get an error, and my transaction will now be in the aborted state. So if I try to run this statement again, I get an error that says the current transaction is aborted. Commands will be ignored until the end of the transaction. So if you're following along and you make an error as well when you're within a transaction block, just come down and issue the rollback command, and now you can start the transaction again. So that's how you use the insert statement to insert records into a table. You can insert fixed values, or you can insert the results of a query. And we had a very quick look at how you can use transactions to roll back any changes you make to your database. Jump on over to the exercises now, and remember, when working through the exercises, always perform all your changes within a transaction so that you can undo them and leave the database in its original state.